Good afternoon. Thank you for joining us for Research 411, a talk show focused on sharing best practices and trending research topics delivered by professional staff and prominent UT Dallas researchers from various disciplines. I am Tiffany Willoughby, Research Education Programs and Outreach Manager in the Office of Research. I will moderate today's discussion. Joining me today to talk about wind turbines is Dr. Todd Griffith. Dr. D. Todd Griffith is an associate professor of mechanical engineering at the University of Texas at Dallas, where he also serves as deputy director of the UTD Center for Wind Energy. His research is in the area of renewable energy with a focus on developing new technologies to enable cost-effective, reliable, and large-scale wind energy systems. Dr. Griffith and his research team are designing the world's largest wind turbines. Prior to joining UT Dallas in fall of 2017, Dr. Griffith was a researcher, principal member of the technical staff at Sandia National Laboratories in the departments of Wind Energy, Water Power, and Structural Dynamics Research from 2005 to 2017. He was the technical lead for Sandia's offshore wind energy program, which focused on developing new technology for offshore wind systems for the U.S. Department of Energy. Dr. Griffith, welcome.
Thank you, Tiffany, and thank you for the opportunity to join you and the attendees here today.
You're most welcome. We're happy you're here to give us some information about your research. And in saying that, can you please share with the audience what your research is?
Sure. So our research group here at UT Dallas, which consists of graduate students, postdoctoral researchers, several undergraduate researchers, we're focused on the design of wind turbines. All right, so we're focused on new technologies, new design approaches. Our overall goal is to develop new designs that are highly reliable, durable, cost-effective. All right, of course, one of the important factors in the electricity generation is cost of electricity and, of course, reliability as well. And so we're really focused on looking at those technologies that are 5, 10 years, even further out. Those technologies include new approaches for wind turbines on land, which we call land-based wind energy. They also involve new solutions for offshore wind in shallow water, near the coast, or even in deeper waters where we require floating systems. And so in designing a wind turbine, our work is very multidisciplinary. This involves a number of different fields. You could think about different degrees or different research areas, including aerodynamics, structural design, materials, control systems, etc. And this research also involves a lot of collaboration as well, and that starts within our UT Dallas Center for Wind Energy. So wind energy is a major research focus at UT Dallas. We have a number of faculty and graduate students across the entire university, in particular in mechanical engineering. So there's a lot of collaboration of our group with the other faculty in the UTD Center for Wind Energy. And just to emphasize what we do in our group in terms of design, a lot of our work focuses on numerical paper studies, but we're also proud of the fact that occasionally we have an opportunity to fabricate our design and test it. And so one of the first projects with my graduate students here at UT Dallas was the design of a new two-bladed wind turbine prototype. And in October of 2018, that prototype was fabricated, so it was constructed, and it was delivered to the National Wind Technology Center located in Boulder, Colorado, for field testing. And that Those two blades are still being tested today. They're still in operation to demonstrate that concept. We actually have a video to share with the attendees here to show you those two blades when they were installed on this wind turbine. And just for scale, what you're going to see here are two blades being installed. Each blade is 21 meters long. That's about 70 feet. Each blade is about 70 feet. Here in a moment, you'll see these blades being installed and assembled into place. There we go. And that completes the assembly. And so this happened back in October 2018. And my very first two graduate students at UT Dallas were co-designers of this new rotor system. So that's one of the really exciting things we have opportunity to do, is actually design and fabricate a design and test it and see how well it works. And in this case, the design has worked quite well. So yeah, that's a quick introduction, Tiffany, to our overall research in our group.
Thank you, Dr. Griffith. We appreciate that, and are thrilled that we were able to associate a video with your research. Now, can you tell us a little bit about how you became interested in wind energy?
Yeah, great question. Kind of take a step down memory lane, I guess. But as an undergraduate researcher, I started working in aerospace structures, and so I had an opportunity to work on a NASA-funded project looking at very large space structures. Had an opportunity to do several internships, and so I've always been interested in large structural designs, and I've always been interested in really pushing the boundary on what's possible for these large designs, and also you know, building things, you know, and so that's really got me interested in engineering in the first place. After I finished my PhD work, I took a research position at, as you mentioned, Sandia National Laboratories, which is a federal government research lab. And my first project at Sandia was to do a test on a wind turbine blade. And this was a new field to me. Of course, I had learned about wind energy before and knew some of the basics, but this was my first opportunity to really do a deep dive. And this area just really resonated with me. I really love working in an area that has so much societal benefit, and it's also such a challenging area as well to come up with these new designs. And so from there, we did that initial test, and I gradually became more and more involved in different aspects of wind energy development. I had an opportunity to begin doing wind turbine design work. So at that time, the largest wind turbine blade in the world was about 60 meters. All right, 60 meters. That's about 60 yards if you want to compare to a football field. And so the question was, could we go to a 100-meter long wind turbine blade, something the length of a football field? So we did some design studies of how to go larger and larger and develop some engineering solutions and approaches to get there. And so that's really been the focus of my research for the past 10 years or so. You know, starting just with that first small wind turbine blade test and then moving into some new design areas.
Dr. Griffith, that is very interesting, and I wanted to share with you that I saw my first wind turbine while living in Okinawa, Japan in 2000. Now, Okinawa is part of the Ryukyu Prefecture, one of many islands between Japan and Taiwan. The wind turbine faced the west, towering over the East China Sea. And over the last 2 decades, I've observed wind turbine growth, so to speak, from the plains of Illinois to deep in the heart of Texas. Can you tell us a little bit about the history of wind turbines?
Absolutely, yeah. Using wind turbines for some useful purpose is far from being a new idea. Um, Wind energy, the wind has been used for 1,000, even we can go back close to 2,000 years looking at examples of how the wind has been used in what we call windmills to pump water, to grind grain, and this is really, the world over. You see my collection of flags here. I mean, I really always like to emphasize, the international nature of wind energy. Of course, with the collaborations we have and in our group and across our wind energy center, but really, if you go and study the history worldwide, the wind has been used for some useful purpose for a very long time. However, it's really in more recent times that we've really seen this rapid growth of the use of the wind for electricity generation. And we could go back to the early 1900s. I mean, not too long after the invention of the light bulb, we started seeing some wind turbines being designed and fabricated, built, and tested here in the United States. The Putnam machine, for example, was an early, very large turbine in the early 1900s. Really significant advancement in wind turbine technology for electricity generation started happening around the 1970s. There was a lot of investment by the U.S. Department of Energy. There was a lot of research starting in Europe as well at that time. And it was really in response to an oil crisis in the 1970s, and really a look to producing electricity from domestic renewable sources. And so that really leads us to where we are today with wind energy being such a growing field and really the number one new source of electricity generation, again, coming from wind energy. And that's coming, like you mentioned, from on land. Texas is a major producer of wind energy. All right, there are huge installations of wind turbines out in mostly in West Texas. Offshore is really the growing area. You mentioned Japan. There's major research activity in floating offshore wind in Japan, and then in the U.S. as well. This is really what the future looks like in terms of major growth offshore and continued growth on land as well.
Thank you, Dr. Griffith. And yes, as the use of wind turbines as a source of energy continues to grow, what energy source will be replaced or used less, and why?
Yeah, that's a good question. So our current electricity mix here in the U.S., we can break down into different sources of generation, and these include in no particular order, coal-fired power plants, natural gas, nuclear power, hydroelectric, and then all the renewables, including wind energy and solar. And so today, the largest percentage of generation is still in those fossil fuel-based sources of coal-powered and natural gas, as well as nuclear as well, being another major contributor. But if we look in terms of new installed capacity, wind energy has been leading the way for many, many years now in terms of, if we look at the new capacity being added, it's wind energy. Why is that? Well, wind energy is reliable. Wind energy is cost effective. There's been a huge amount of wind turbine optimization based on scientific development such as that going on here at UT Dallas to improve wind turbine technology. to a point where wind turbines are very reliable and very cost effective, and even more cost effective than the other sources that I mentioned. And that's why they're being adopted. So what's being replaced? Well, mostly what's being replaced are the fossil fuel sources. All right, so those are the sources that are being replaced due to their, I'll say, non-renewable nature, and really an overall general consensus from the population to move toward energy sources that are renewable, but also domestic. Okay, we can produce electricity to meet 100% of U.S. electricity needs from wind energy, including land-based and offshore wind. So that's really a major factor worldwide for greater adoption of wind energy.
Are the wind turbines built to withstand all weather conditions, or do they have a threshold? For example, when building offshore wind turbines, I'm sure you need to account for typhoons in the Pacific and hurricanes in the Atlantic, and in the Midwest, you need to account for tornado force winds, and in other locations, perhaps earthquakes.
Yeah, this is a very important topic in wind turbine design. It's also a very timely one because we recently experienced back in early February a major weather event here in Texas as well. But what I'll say is wind turbines have been designed to address all of the above. All right, so everything you can imagine, whether it be cold weather conditions, wind turbines have been designed to operate and operate reliably under those conditions. And the same can be said for the hurricane conditions as well. You know, the wind turbine design standards and address the design of a wind turbine in very high wind conditions like you would see in a typhoon or hurricane condition. And the same goes for other weather events too. If we're looking on land, we can talk about thunderstorms and downburst events and etc. These are addressed in the design process. Now, all of the options that we have available as engineers are not always used. So it really depends upon the site-specific conditions. And so if you're in a cold weather location, like if we go far north to Canada or in the far north US and Minnesota, North Dakota, etc., there are packages that we can add. You can think about this as the kind of packages you might add when you're purchasing a new automobile. You have lots of options. Well, you want to purchase the options that are, you know, most relevant in the case of a wind turbine design to the location where you're going to put that wind turbine. And so anti-icing systems are available. You know, different control strategies are available to address these issues. And then we also address it in the design phase as well for everything you mentioned. Hurricane conditions, cold weather events, etc.
Thank you, Dr. Griffith. Can you explain the benefits we'll see from the world's largest turbine with blades over 850 feet?
Yeah, absolutely. This is really at the heart of what our research group is focused on, is designing bigger and bigger wind turbines. And in fact, in our group, as you mentioned in the introduction, we're focused on designing the world's largest wind turbines with blades and length up to 850 feet. I mean, we're talking 2.5 times the length of a football field. So why would you want to do that? All right, well, going larger and larger with blade size allows you to capture more energy with the wind turbine. Okay, so the size of the blade dictates the amount of power that you can capture out of the wind. And this power that you're able to capture depends upon the swept area of the rotor, the so-called swept area. So you have this blade, and I'll just use my arm to show. You have a blade, and that blade's rotating, and it sweeps out a big circle. All right, if you think about the tip of that blade sweeping out a big circle, the power is proportional to the area of that circle. And that area, as we all learn in school, is pi r squared. All right, so r is the length of the blade, the radius of this circle. And so by making this blade longer and longer, we're able to increase the area and increase the energy capture. And just to give you an example, if we double the length of the blade, we're going to get 4 times as much power, okay, 2 squared. And so that really motivates us to go bigger and bigger, and that's exactly what we've seen in the wind energy industry. From the early 1980s, wind turbines had blades that were around 9 meters long. Today, wind turbines are being installed that have blades over 110 meters. We're already past 100 meters. And now we're looking at even beyond 200 meters. So the big reason is to capture more energy. But as you might expect, making these blades longer and longer, you encounter a number of design challenges. And really, those challenges are what we address in our research. So how do we enable getting to that very large blade that captures more energy? And oh, by the way, as we capture more energy, we can dramatically reduce the cost of electricity, which the consumer loves, we all love. All right, so that's our big motivation for going bigger and bigger. The structural design of such a large blade, I mean, keep in mind, wind turbines are the largest rotating structures in the world, and these blades, because they're rotating due to the wind loads, are under tremendous forces. And that's really where our design research comes in to understand what are the new technologies that we can bring into a wind turbine to allow us to go bigger and bigger and to continue going bigger and bigger.
Thank you, Dr. Griffith. We actually have a few questions coming in from the audience. And the first question is, are there barriers to getting more wind turbines installed more widely?
So, yeah, are there barriers? And we can break this down into in the different regions where we would think about installing wind turbines. And let's talk about land-based wind first. Installing wind turbines on land sometimes involves placing wind turbines in complex terrain. Okay, so we may be putting wind turbines on a ridge top or a mountain top. And so the transportation issues and the transportation infrastructure is one of the challenges we face there. As we've talked about, wind turbines are very large. All right, and so another challenge that we face with land-based wind turbines is the installation, or rather the transportation of these very large components. And so how do we transport a single 100-meter blade, in one piece? That's possible. However, there are some locations where it's not possible because of the limitations on the size of highway underpasses. We all know when a bridge goes over the highway, there's some limited amount of space we have to be able to go underneath those bridges. And so wind turbine components are large enough now that in some cases they don't fit. And so how do we address that? In our group, we have several students looking at segmentation. All right, we fabricate a very large blade in multiple pieces. Maybe it's in 2 pieces or 3 or 4 pieces. And then it's easier to transport those smaller pieces onto site. So let's talk a little bit about barriers for offshore wind. All right, this is really now an emerging area. You're probably hearing a lot in the news about ramp up and plans for greater offshore wind deployment. So the main challenge for offshore wind has really been the cost. All right, the cost of offshore wind has been more expensive just because it's more challenging to do operations at sea. We need special vessels, we need large vessels, we're talking about ships, and the cost has been the major issue. However, there's been really major investment in research in the past 10 years in offshore wind, and the costs are coming down rapidly. All right, the costs are coming down rapidly based on new technologies that are coming in to the market. So that's really the principal challenge offshore is cost. And then secondly, related to that is accessibility. Going offshore, the winds and the wave environment can be quite extreme. So this is a challenge for doing any type of work offshore, including installing the turbine, doing inspections and maintenance on the turbine, and so forth.
Dr. Griffith, there are many positives in utilizing wind energy. I have some community members that are concerned about the wind turbines harming the bird population. Can you shed a bit of light on this concern and any other drawbacks to using wind turbines?
Sure. Impacts of wind turbines on wildlife is something that's been studied since the very beginning. And so in a permitting process, this is taken very seriously. This is a requirement for any project to do an environmental survey and to understand if there might be any impacts to birds, avian migratory patterns. We can also talk about bats. This is something that's very important for Texas because I'm sure, as many of you know who are Texans, we have a number of bat populations in the hill country area. And so there's always an environmental survey that's done to address and mitigate those issues. If you look at the data, of course, like I mentioned, we take this very seriously, but you can take a look at the data and see what are the sources of death of birds. And the research shows that in terms of man-made sources, number one on the list are skyscrapers. All right, skyscrapers are number one on the list. And then somewhere down that list, maybe number two or number three, actually, cats are also a major source of bird death. And if you go way down the list, then you get the wind turbines. All right, so wind turbines are way down the list in terms of bird fatalities, because of all the work that's been done. And I'm not going to say it's zero. It's not zero, but it's a very low percentage of the overall issue. And then let's see, when we talk about offshore, the environmental surveys are done for the fish population, whales. Some of the other concerns from wind turbines are noise. All right, so when we put wind turbines close to cities or major population centers, we're concerned about the acoustic noise. And so for that reason, wind turbines are designed to operate in such a way that the noise decibel level is below some acceptable threshold level, so that's not an issue. There are some operating strategies that are deployed called curtailment to seasonally or daily adjust to address the environmental issues. For example, when we know that migratory population of birds is coming, there are ways to approach it by either shutting down the turbines or using deterrent measures like acoustic signatures that can essentially steer away the birds from the wind farm. All right, so I'll just say it's really the environmental issues are looked at very comprehensively, and those are just some of the issues that we look at in terms of impacts to wildlife and then the noise concern, really for humans, but also for wildlife as well, where we address those noise concerns.
Thank you for that detailed explanation. Now we have a few additional questions in the queue. One audience member asks, what is the advantage of offshore wind turbines versus onshore or on land? Yes, so offshore versus on land. Can you provide the pros and cons, please?
Great, that's a great question. So when we go offshore, one of the big benefits is if you look at the population map of the U.S., we have really high population density in the coastal areas. And so if we can put offshore wind turbines near those coastal areas, it can greatly reduce the transmission cost of the grid to get renewable energy to those locations. And in fact, for many coastal regions in the U.S., offshore wind is by far the best renewable energy option. There are other benefits. The wind resource offshore is very strong and steady. All right, we have more consistent wind resource. The higher the wind speeds, also the more power that we can generate. All right, so that's another major advantage. Another advantage is that the winds tend to pick up in the time of day when we want the electricity. And so those winds, if we look in the North Atlantic, we think about off the coast of New York, the state of Maine, the entire Atlantic coast, those winds tend to start picking up in the morning just before people are waking up. And that's when the peak electricity demand is when everybody wakes up, we're cooking, we're preparing lunches, we're taking showers, all of those things. There's a huge increase in electricity demand. Well, the wind is available at that time offshore to address that. And the other thing that's really important is we have no real space constraints. So when we go offshore, we can place those really huge wind turbines offshore without those transportation constraints that we have on land due to terrain and the bridges and the underpasses and all that. But so those are some of the main attractions and benefits to going offshore.
You mentioned maintenance of the wind turbines. What needs to happen to help maintain the wind turbine? How often do they need maintenance? And how long do the turbines last before they need to be replaced?
Yeah, very good question. So the maintenance costs of a wind turbine are really a major factor in the cost. Roughly maybe 30% of the overall cost of electricity come from operations and maintenance. And we have a lot of history now, especially in the last 40 years, about wind turbine performance and knowing which components to go inspect in the wind turbine. And so based on that, we have regular periodic inspections. Typically, there's a regular inspection interval of going out, at least once per year. In some cases, maybe 2 or 3 times per year to go and visually inspect components. But there are a lot of new technologies that are coming into wind as well. I mentioned earlier the example of an automobile, and in our cars we have, a lot of diagnostics that tell us that the tire pressure is low or that we need to check the engine. We have some sensor going bad, etc. So that check the engine light. Those kind of technologies are being added in wind turbines now as well. Wind turbines are located in very remote locations that are difficult to access. And so having that check engine light, having those sensors on board that tell the owners and the operators of these wind turbines that something is going wrong or there might be an impending failure, really helps us do better maintenance actions. Now, the other thing that's really interesting, and this is another area that we work in our group, is developing digital twin models. And so what is a digital twin? Well, it's a virtual numerical model of the wind turbine. So out in the field, we have an actual operating wind turbine, and then the engineer has a numerical model of that wind turbine that he or she can use to do some analysis to evaluate the performance of that wind turbine and then make a decision. All right, what am I going to do? Am I going to continue to operate the turbine, or do I have maybe an unsafe condition that needs to be addressed through inspection, through maintenance, and overall having that digital twin model? And this is really an exciting field, I think, for young engineers to get involved in. Is how do we develop that model, and how do we use that model to do better maintenance, and ultimately, like I mentioned in the very beginning, make the wind turbine more reliable and reduce the cost of electricity. And these are the major goals that we're always going to have for wind energy systems.
Thank you, Dr. Griffith. And I think you've done a really good job of sharing information about how you reduce, reuse, and recycle when you are creating wind energy with wind turbines. I believe I have 2 more questions in the queue, and I'll try to combine them the best that I can. Is there a chance that wind turbines could be made for home installations like home solar panels? And if so, what would be the best materials to use in creating these wind turbines? Would it be similar to the materials that you currently use for on land and offshore?
Yeah, that's a good question. So wind installations at home or on a ranch are definitely possible, and this is I would call this a different market. And so most of the research we do is in what we call utility scale wind. We're talking about wind turbines that generate, you know, on the scale of megawatts of energy, and they're single power plants that can power hundreds, if not thousands, of homes with a single wind turbine. The other area, the other market is distributed wind or small wind turbine development. There are a lot of wind turbines that are available today if you'd like to place one on your property to generate electricity, whether it be on a ranch or on a rooftop. You could go online and do a quick search. There's several options on Amazon as well. I think you know, one of the concerns and challenges though is I think in urban environments, and let's talk about a suburban environment, you're probably going to face a lot of issues with homeowners associations putting turbines on rooftops in suburban areas. However, if you do look into urban areas, you do start seeing you know, uses of wind turbines on rooftops and skyscrapers. There are a number of different technologies that are used. Vertical axis wind turbines, horizontal axis wind turbines. There are even some new developments in bladeless designs as well. So there are wind turbines that do not have rotating components. And so it is possible. There are some options for you out there if you're looking to power your home or your ranch.
Well, Dr. Griffith, our program is about to close, and I want to thank you for being a part of our talk show today to share valuable information with our community. Interested in attending this or another Office of Research event, additional information can be found at research.utdallas.edu. Thank you.